This lesson is for section 8.4 on radical equations. We have one main objective for today, and that's to solve radical equations and to recognize when we can discard extraneous solutions. Now, each of these problems that I'm going to do with you are different from the other, and they get progressively more difficult. So you don't want to cut this video short at all, because I'm going to talk about some methods and some strategies for solving some more difficult radical equations. But let's first talk about what a radical equation is. So a radical equation is an equation which a variable will appear underneath a radical sign. So each of these represents a radical equation, and each of these would have a different method for solving, okay? Now, in general, though, we can take the same steps for solving radical equations, and I've mentioned them here, steps 1 through 5. So I'm going to go through those right now. So when we solve a radical equation, our first step is going to be to state the domain. Now these are going to be a little bit trickier than when we were dealing with fractional equations, but we'll get to that in a second, but it's still a very similar idea. You want to state the domain first. Step 2 is to isolate your radical. Okay, sometimes you'll have more than one radical, but if you only have one radical, you're going to get that radical by itself on one side of the equation. Then you will square both sides. Sometimes we'll cube both sides. It depends on what type of radical we have. And then we try to get rid of all the radicals. So if we have one remaining after we square something, we have to go back to step 1 and start all over again. Okay, we'll do a couple problems where you see more than one radical in the equation. Step 4, you're going to solve the equation just like normal. Okay, you might have to factor and you might have to use the quadratic formula. It just depends on each problem. Then finally, you make sure that you check for extraneous solutions. Remember, those are solutions that do not work in the original problem. When you write your answer, you're going to write it as a solution set. So if 4 is the only solution to a particular equation, we write 4 inside those brackets. If there is no solution, we can write the empty set like this, or we can put a 0 with a slash through it. Okay, we just don't want to write that because that's poor notation. Okay, so this would be wrong. All right, let's start with example 1. Okay, our first step in solving number 1 is to state our domain. So our domain is a little bit trickier than when we were dealing with fractional equations. Remember, that was when we got something like all reals and we threw out a couple x values. Here, though, we have to be a little bit more considerate because we have this square root symbol. When you take the square root of a negative value, you get an imaginary number. It's not real. So we don't want this quantity here to be anything that's negative. In other words, we want x minus 1 to be greater than or equal to 0. It can be 0 or positive, but it cannot be negative. So if I solve here, I end up with x is greater than or equal to 1. So there's my domain. Okay. Now, my second step is to make sure I isolate the radical. So here's my radical, which means I want to move this x value. So I'm going to subtract x to the other side here. Write that as 3 minus x. So I have 3 minus x equals root x minus 1. Now, after I isolate that radical, I want to get rid of the radical by squaring both sides of this equation. I don't want to just square one side. I have to do it to both sides. So I can square both sides of this equation because that'll get rid of that radical. And on the left-hand side, this is where you need to be good at your patterns. Remember, your first term is going to be squared. Your middle term will be double the product of 3 and negative x, so that gives me negative 6x. And the last term will be negative x squared, which is going to give me positive x squared. On the right-hand side, after I square that radical, I just am left with x minus 1. So that's why it's really helpful to be able to square both sides, because it drops the radical and leaves you with just the inside. Now I have just a quadratic, which is really easy for me to solve. If I move that x to the other side and I rearrange the terms, I have x squared minus 7x. If I add the 1, I end up with plus 10. So here I have to factor, and I'll have two different solutions. So I have x equals 5 and x equals 2. Now both of these numbers do fit within your domain. They are greater than or equal to 1. If one of them was negative, we throw it out right away. But you always must check to see if your solutions actually work in the original problem. So let's check to see if that actually works, 5 and 2. If we plug in 2, we have 3 equals 2 plus the square root of 2 minus 1 is 1. So we add 2 plus 1 and we get 3. So 2 for sure works. So I'm going to put that in my solution set. Now when I try 5, I have 3 equals 5 plus the square root of 5 minus 1 is 4. And if I take 5 plus 2, I end up with 7. Clearly, 3 does not equal 7. So 5 doesn't actually work in the original problem, which means it's an extraneous solution. Okay, so my only solution here is 2, and then make sure that you clearly show what your solution is. Okay, so that's why these can be tricky, because it looks like 5 would work since it fits in the domain, but it doesn't actually work in your original problem. So always double check your answers. Okay, in example 2, I'm going to find the domain first. So I set 2x greater than or equal to 0. If I solve and divide by 2, I end up with a domain of x is greater than or equal to 0. So x must be positive or 0. Now I want to isolate my radical next, so I'm going to subtract that 6. Then I'm going to divide by 3 because I want to isolate that radical completely. So I have root 2x equaling negative 2. Now at this point, I already know that this particular problem will have no solution. So it's the empty set, okay? The reason why is because I have a radical equaling a negative value. Remember, you can't take the square root of something and get a negative value. So this has no solution. But let's say I didn't recognize that right away and I continued to solve. So I would square both sides. And I'll end up with 2x, because that radical will drop after we square it, equaling positive 4. So I end up with x equals 2. Now, even though x equals 2 is in the domain, if I plug 2 back into the original equation, I have 6 plus 3 times the square root of 2 times 2, and it's supposed to equal 0. Well, clearly here, I end up with 6 plus 3 times the square root of 4 is 2, and that does not equal 0. 6 plus 6 does not equal 0, so I would still end up with no solution. It's just that sometimes it's faster for you to be able to recognize when you have a radical equaling a negative number. So anytime we see a radical equaling a negative number over here, this will have no solution. Okay, just a little bit of a shortcut for you. Okay, and number 3, finding the domain in this problem is going to be a little bit trickier because I have 2 different radicals. So if I set each of those quantities greater than or equal to 0, I end up with 2 different inequalities. I have x is greater than or equal to negative 4, and x is greater than or equal to 4. Now you have to pick the more restrictive inequality. So what I mean by that is, let's say we get x equals negative 2. Okay, x equals negative 2 fits for this inequality. It is greater than negative 4, so it would work in this particular radical. But as soon as we try to plug it into the other inequality, it won't work, right? X is clearly not bigger than 4. So you have to pick the more restrictive one, and you can see it on a number line. If we have, here's negative 4 and here's 4, this inequality is saying everything greater than or equal to 4, while this one is saying, wait, these values don't work. You got to only pick values that are greater than or equal to 4. So we have to go with the more restrictive one, which is going to be x is greater than or equal to 4. So there's our domain. Okay, now that we have our domain written, I want to isolate one of the radicals. It doesn't matter which one I choose. I'm just going to pick the first one, and we'll move that second radical to the other side. So we have the square root of x plus 4 equaling 4 minus the square root of x minus 4. So now that I have a radical isolated, I can square both sides of the equation. Now when I square both sides of the equation, the left-hand side is really easy because that'll just drop to x plus 4. But the right-hand side requires a little bit more thinking. I want you to be really fast with your special products. If you're good with your special products, then this won't take you a long time to FOIL. You're going to have to do this so many times in a problem that it's better for you to develop the skill to just multiply this out in your head, okay? So to multiply this out in our head, we take 4 and we square it, we get 16. To get the middle term, we have to double, so we're going to multiply by 2. We have a negative sign because we're subtracting these two, but we're going to double the product of 4 and root x minus 4. So we have to multiply 4 times root x minus 4. A lot of students will multiply the 4 inside there, and it doesn't work like that. If we were to multiply 4 and the square root of 2, that doesn't automatically equal the square root of 8, right? We know we cannot multiply here, so we should not try to drag that 4 inside. So this ends up being 4 times root x minus 4 times 2. And the last term here will be that second term squared, so we get x minus 4, okay? So I'm just foiling, but in my head. Now, if I simplify, I have 16 minus 8 root x minus 4, okay? On the left-hand side, I'm going to bring down that x plus 4. Now, I want to isolate, again, the radical. So let's isolate that radical by moving these terms to the other side. So if I want to move that x, it actually cancels out that x here. The 16, if I move it to the other side, becomes negative 12. And then if I add the 4, I'll get negative 8. Okay, so I have negative 8 equals, on this hand side, I have negative 8 root x minus 4. Okay, so I can isolate the radical even further from here because I can divide by negative 8 on both sides of this equation. So this one's a little bit different than number 2. Even though I have the radical here equaling a negative, because I have this negative here, it changes it to a positive. So I have positive 1 equals the square root of x minus 4. Now I'm going to square both sides again because I've isolated the radical one more time. So I'll square both sides. I end up with 1 equaling x minus 4. Now I'll add 4 to the other side, so I get x equals 5. Remember, you want to make sure that you double check this solution back in the original equation. So we have 5 plus 4, which is 9. So we have the square root of 9, which is 3. Whoops. And then the square root of 5 minus 4 is 1, which does equal 4. So this would be our only solution to this particular equation. All right, in number 4, here we're seeing a cube root instead of a square root. So this problem is going to be a little bit different in terms of the domain and how we solve it. So I want to talk first about the domain. Remember when we simplified things like the cube root of 27 or even the cube root of negative 27, here we would get positive 3, and here we would get negative 3, which means we don't get an imaginary number when we take a cube root of a negative number. That means that we can stick positive and negative values into that cube root, so the domain here is actually all reals. And we're going to see the reason why that domain is all reals when we try to graph cube root functions also in the next couple lessons. But anyhow, now that we have that radical, we already have it isolated, right? We can actually get rid of it if we cube both sides. So we can't square both sides, we need to cube both sides. By cubing both sides, now we get rid of that cube root. So we have 3x minus 1 equaling 2 to the third power, which is 8. So I solve here and I get x equals 3. So if I plug 3 back into the original equation here, I have 9 minus 1. So the cube root of 8 should equal 2, and in fact it does. So there is my solution, 3. Okay, in number 5, if I try to write the domain of this particular equation here, I need to set each of these greater than or equal to 0. So I have one inequality, x is greater than or equal to 0. Here I have x is going to be greater than or equal to 4/3 after I solve. And here I would have x is greater than or equal to 4/3 as well. The problem is that if I plug in 4/3 here, I end up with 0 in that radical. And if I take the square root of 0, I get 0. So I'm dividing by 0. So I don't actually want a value of 4/3 here. I'm going to pick x greater than 4/3, which means that this is already more restrictive than either of those. So there's my domain. So x must be greater than 4/3. Okay, I move this a little bit so I have more room. Now, I have a very specific strategy to solve number 5. Because I have a radical in the denominator, I want to get rid of it, okay? If I multiply by root 4x minus 3 on one side, I have to make sure I multiply by root 4x minus 3 on the other side. Okay, you always have to balance both sides of the equation. Now on the right hand side, that's very advantageous because that gets rid of the radical completely and it leaves me with 1. And on the left hand side, I need to distribute that radical to both terms. So I'm just distributing here root 4x minus 3 multiplied by 2 times root x. Now remember, when you multiply radicals, like root 3 times root 2, that turns into root 6. If you had 2 root 3 times root 2, that would end up being 2 root 6. So that 2 here just stays on the outside because it's not inside a radical, but stuff inside the radical can multiply, okay? So in this case, when we multiply root 4x minus 3 times 2 root x, this turns into 2 times, these will be able to multiply, so I'll have 4x squared minus 3x. So I distribute that x to both of these parts, okay? Now when I distribute that second part here, so root 4x minus 3 times root 4x minus 3, obviously we know that those radicals will drop. Make sure though that you keep this sign. That's an error that students will often make, so we want to drop that sign, make that minus, and then in parentheses I will put the quantity that's left over from the radical. The reason why I'm putting it in parentheses is to remind me that I have to distribute that negative to the 3, okay? Alright, so by just multiplying by root 4x minus 3 on both sides, I've gotten rid of 2 of the radicals. That radical is no longer there, and that radical is no longer there. So I only have a radical with, or an equation with one radical now. So that was very helpful. So now I'm just going to distribute and then isolate the radical here. So I have 2 times the square root of 4x squared minus 3x minus 4x plus 3 equals 1. If I move the 4x and the 3 over to the other side, I now have positive 4x minus 2. Okay, now from here I can solve this problem with 2 different methods. First, I can divide out that 2 to completely isolate that radical. And if I do that, I'm left with 4x squared minus 3x underneath that radical equaling, on the right-hand side, 2x minus 1. So that would be okay to do. Okay, I can also, instead though, go straight to squaring both sides of the equation. And that's the method I'm going to pick first. So I'm going to square both sides of this equation. When I square both sides of the equation, I need to make sure I square the 2 out in front. A lot of students will forget to do that. So I have 4 times, now when I square that radical, it'll drop the radical and keep the inside. So I have 4x squared minus 3x multiplied by 4. And on the right-hand side, when I distribute and I FOIL those terms in my head, I end up with 16x squared minus 16x plus 4. Now I'm just showing you why when you square this, you have to make sure you square that term, because sometimes it's not advantageous to you to divide out that number out in front of the radical. So let's say instead the problem had been slightly different. We end up with 3 times 4x squared minus 3x equaling 4x minus 2. In this case, to divide by 3 and to completely isolate that radical will cause a nightmare for me, because now I have to FOIL something with fractions in it, and I have to solve with fractions, and it's going to be a lot tougher. Instead, in this problem, because this does not give me nice integer coefficients for the x and the number there, I'm going to leave that 3 completely where it's at, and then I square both sides of the equation. So it's okay to have a number out in front, but you just have to remember, a lot of students will forget to square that number out in front. So you have 9 times 4x squared minus 3x, okay? And then over on the other side, we'd square here too. All right, now let's go back to the actual problem here. I'm just going to distribute, so I have 16x squared minus 12x equaling 16x squared minus 16x plus 4. Now the 16x's cancel each other out. If I add that 16x to the other side, I have 4x equaling 4. So I end up with x equaling 1. Now you can check that if x equals 1 is plugged into here, you will get an actual solution. I've already done that, so I'm just going to write in my solution set here, x is equal to 1. All right, now finding the domain in number 6 is a lot tougher than the ones that we've worked on so far, because now we have quadratics inside that radical. This is actually something that you cover in pre-calculus next year, so it's not really appropriate for this course. So we're going to skip finding the domain, which means that when we find our final answer, we need to make sure we check that it's not an extraneous solution. Okay, so let's just skip right ahead to isolating one of these radicals. So I'm going to get this radical by itself, and then I'll move this one to the other side. So I have the square root of x squared plus 5x minus 6 equaling 1 minus the square root of x squared plus 3x minus 3. Now that the radical has been isolated, I'm going to square both sides of this equation. On the left-hand side, that radical will drop, leaving me with x squared plus 5x minus 6. And on the right-hand side, I'll FOIL this quickly. So I have 1 squared, and then I find the product of 1 and the radical here, and then double it. So I have minus 2 times the square root of x squared plus 3x minus 3. Then for the last term, I need to square that radical. So I'm essentially squaring negative root x squared plus 3x minus 3. Okay, so that's why it ends up being positive, because we're squaring that, but also the radical will completely drop. So I have x squared plus 3x minus 3. Now I think it's best to probably just simplify the right-hand side. So I have this 1 and this negative 3. So let's write the radical first. So I have negative 2 root x squared plus 3x minus 3 plus an x squared plus 3x minus 2. Okay, that's with those two combined. Okay, now on the right-hand side, since I have that x squared, those will cancel these out if I try to move it to the other side. And then if I move that 3x to the other side, I have 2x. If I add the 2 to the other side, now I have minus 4. So I have 2x minus 4 equaling negative 2 times the square root of x squared plus 3x minus 3. Now in this case, I'm going to divide by negative 2 so I can isolate that radical completely, because here I see that if I try to divide 2 and negative 4 by negative 2, I'll still get some nice integers. So on the left-hand side, I'll end up with negative x plus 2, and on the right-hand side, I'll have root x squared plus 3x minus 3. All right, now that the radical's been isolated, I'm going to square both sides. So if I FOIL the left-hand side, I end up with positive x squared minus 4x plus 4. On the right-hand side, that radical will drop. So I have x squared plus 3x minus 3. Now I have x squareds on both sides, so those will cancel. I bring that 3x to the other side, and I have negative 7x. I bring the 4 to the other side, and I'll have negative 7. So I end up with x equaling 1. Now remember, we didn't write our domain, so I want to double check that that actually works in the original problem. So if I plug in 1 back inside here, for every x, I have the square root of 1 squared, which is 1, plus 5 times 1 minus 6. So this first radical will give me 0. Then I have plus the square root of 1 plus 3 minus 3. So this will give me the square root of 1, which is 1. So that definitely ends up working out. So my solution here is 1. Okay, to get some practice, I want you to try number 7 and then check with a key, and we'll move on to number 8. Okay, we finish off the lesson with, I think, the most difficult problem of the lesson here. We have a fractional equation that also contains radicals in it. So when I talk about the domain here, I have to think about the denominators and the radicals. Now for the radicals, I'll have x is greater than or equal to 0. The problem is, though, that if x is equal to 1, then this denominator here is equal to 0, and so is this denominator. So I'm going to use all real numbers greater than or equal to 0, except x cannot equal 1. Now to solve this equation, I could, if I wanted to, try to multiply by 1 minus root x on both sides of the equation. Okay, just like we did in a previous problem. Even though it gets rid of the denominator here, it does not help us on the left-hand side, so this would be extra work that I don't want to do. Okay, that would take me a long time to try to solve it that way. Instead, if I look at these two terms here, those two denominators, I notice that if I multiply 1 plus root x times 1 minus root x. This is a difference of two squares. So we would get 1 minus x, right? If we squared the first term, we squared the second term, we would get 1 minus x, which is this denominator here. So this is the LCD for this particular equation, which means that the second fraction here needs to be multiplied by 1 minus root x in the numerator. And over here in the right-hand side, we need to multiply this by 1 plus root x. The first fraction obviously already contains that least common denominator, so we don't need to worry about that. So now I have 1 over 1 minus x plus 1 minus root x over 1 minus x equaling 1 plus root x over 1 minus x. Now again, once you have your common denominators here, you can get rid of it all by multiplying by 1 minus x on both sides. You don't actually have to show this work because basically we just clear the denominator and we start solving the numerator, okay? So I'm left with this equation here. So let me erase. So I have 1 plus 1 minus root x equaling 1 plus root x. So we'll simplify. So I have 2 minus root x equaling 1 plus root x. Now if I want to isolate the radical here, I can subtract 1 to the other side here. So I have 1 minus root x equaling root x. Now in this case, okay, because the radicals are the exact same, that's like having root 3 and another root 3 here, I can put those together. So I actually have, if I add root x to the other side, I have 1 equaling 2 root x. Okay, root x plus root x gives me 2 root x. Now if I divide by 2, I have 1/2 equaling root x. So now I can square both sides, and I have x equaling 1/4. So this is the equation, this is the solution to this particular equation. Now if you hadn't recognized that you can add the root x and the root x here, you can still do this problem like we normally would. So I'm going to erase here, and I'm going to square both sides of the equation first, since I have that isolated. So I'll square both sides. So I have x equaling, using my FOILing rule here, I have 1 minus 2 root x plus x. And then if I cancel those x's out here, since they're the same on both sides, I end up with 1 minus 2 root x equaling 0. So I will subtract the 1, and then I'll divide by -2. So I have root x equaling positive 1/2, and I'm right back to the exact same equation. So I solve and I get x equals 1/4. Now let's make sure that this actually works in the original problem. Now when we plug 1/4 back into the original equation, we should get 1 over 1 minus 1/4. So this is equivalent to 1 over 3/4. So when you divide 1 by 3/4, you're really multiplying by the reciprocal. So we take that and we get 4/3. So that first fraction here is going to be 4/3. Now for the second fraction, we get 1 over 1 plus the square root of 1/4 is 1/2. So 1 over 1 and 1/2 is 3/2. If I multiply by the reciprocal here, I end up with 2/3. So this is 4/3 plus 2/3. Okay, so that's going to be 6/3, which is equal to 2. Now on the right-hand side, let me erase here, get some more room. On the right-hand side, I have 1 over 1 minus 1/2. So this is 1 over 1/2. Again, if I multiply by the reciprocal, that's equal to 2. So I have 2 equals 2, which means that for sure is the only solution to this original equation. So my solution, I write that as a solution set 1/4. Okay, that is the end of the lesson, so nice job. I know these problems are all tricky. They have something different in each one of them. It takes a lot of practice to get good at this stuff, but I am fully convinced that you'll be able to do it as long as you have taken good notes and you're replaying parts if they don't make sense. So come into class asking good questions and be ready to work. Nice job. See you guys tomorrow.